This question is from the GATE Physics paper 2020. This is a numerical answer type question having 2 marks, and the topic of the question is quantum mechanics. The question is, the radial wave function of a particle in a central potential is given by r as a function of small r, that is position, equals to a times small r by a times exponential of minus small r divided by 2a, where a is the normalization constant and small a is positive constant of suitable dimensions. If gamma a is the most probable distance of the particle from the force center, the value of gamma is, so we have to find the value of gamma so that the gamma a is the most probable distance of the particle from the force center in this question. Let us see how to solve this problem. According to the question, the radial wave function is given by r as a function of position small r equals to a times r divided by a times exponential of minus r by 2a. Therefore, the probability of finding the particle between r and r plus dr is given by p as a function of r times dr equals to 4 pi r square times mod of capital R as a function of smaller mod square equals to 4 pi a square divided by a square times r to the power 4 times exponential of minus r by a times dr. Here a is the normalization constant and a is the positive constant of suitable dimensions. To find the most probable distance r of the particle from the force center, or the value of r where the probability of finding the particle is maximum, we can say in this case the derivative of the probability density function Pr with respect to the position r should be 0. So this will give ddr of 4 pi a square divided by small square times r to the power 4 times exponential of r minus r by a equals to 0. So if we do the derivatives, so we'll get 4r cube times exponential of minus r by a plus r to the power 4 times minus 1 by a times exponential of minus r by a, that is equal to 0. So we can do the little rearrangement here. So we'll get 4 minus r by a times r cube times exponential of minus r by a equals to 0. Therefore, we can say 4 minus r by a equals to 0, since the other terms with it, that is r cube times exponential minus r by a, that cannot be 0 here. So from here we will get r equals to 4a, given the most probable distance is gamma a. So if we compare this with 4a, then we'll get gamma value is 4. So if gamma a is the most probable distance of the particle from the force center, then the value of gamma will be 4. Now we will discuss some important tricks to solve this kind of problem. So the radial function given in the question is similar to the radial part of the hydrogen atom wave function. For the hydrogen atom problem, if the radial part of the hydrogen atom is proportional to exponential of minus r divided by Na, therefore the principal quantum number in that case will be n. And for the principal quantum number n, the probability of finding the particle or electron in the hydrogen atom problem is maximum at r equals to n square a. So if we use this relation, so in the given question it is the n value is 2. So the most probable distance will be r equals to 2 square a, that is 4a. So our gamma value will be 4 in that case. So we have solved this problem, and also we have discussed some important tricks to solve this type of problem very easily. And we found that the gamma value in this question is 4.